Hello kids, Shubhamangalam, Athletic Scholars, myself Subdeep. So I am going to take a class 10 for today, chapter 1, reflection of light at curved surfaces. So we are going to continue with where we left. And yes, we were talking about spherical mirrors in the previous video. And I told you how was this word coined? From where do we get the terminology spherical mirrors? Okay, so I told you it comes from the word sphere. Okay, if I divide the sphere into half or cut the sphere into a particular shape, I can actually understand that this will be my concave shape and this is my convex respectively. Okay, so from now onwards, you are going to refer the spherical mirrors as nothing but the concave and the convex mirrors. You need to remember one more thing, that in a concave mirror, you see these lines over here, these are the furnished portion. So the incident light is going to fall on the interior portion in a concave mirror. Okay, and in a convex mirror, the incident light is going to fall on the bulged portion. Okay, you need to remember these two things. Further, we need to understand the two laws of reflection for this chapter very well. I'll repeat it for you. The first law states that all the three rays, the normal ray, the incident ray, and the reflected ray, lie on the same plane. And the second law states that angle of incidence is equal to angle of reflection. So you need to remember one more thing, that in a plane mirror, okay, if this was considered as a plane mirror and I draw a perpendicular to this is nothing but my normal ray. Okay, now this is the incident and this is the reflected. This is the angle of incidence, this is the angle of reflection. Now we need to understand where am I going to draw the normal, incident and reflected in terms of concave and convex mirrors. Did you understand the point over here? It was very easy to draw the three rays when we are considering a plane mirror. But how are we going to draw these three rays when we are considering concave and convex mirrors? Remember, concave and convex mirrors are nothing but spherical mirrors. They are called so because they are like a part of a sphere. They are a part of a sphere. Okay? So we were talking about that the perpendicular line in a plane mirror is nothing but the normal ray. So for to understand how to draw normal rays for curved surfaces and how to draw the incident rays and reflected rays for curved surfaces, we need to go through a certain activity. Okay, we are on page number 2 and I hope you have opened your textbook and you're looking at these three figures on your textbook. It's figure number 1A, 1B and 1C. Okay class, so here we are taking the sole of your footwear or the slipper that you wear. We are going to consider the sole of your slipper or a rubber foam. Okay, and basically cut it into this shape. And when I cut it into this shape, I am going to fix 4 nails so that they are perpendicular to the rubber foam. Do you understand? I am going to fix 4 nails in the rubber foam in such a way as they are making a 90-degree angle. Do you see this over here? I am fixing them perpendicular into the rubber foam. So can I say that these act as normal rays? These represent the normal rays on a plane surface. So here my rubber foam, which is erect in shape, is going to represent the plane surface, and these fixed iron nails which are perpendicularly fixed into the rubber foam are going to represent my normal rays. Did you understand my point over here? Okay, so we studied about two kinds of spherical mirrors, the concave and the convex. Let's deal with the concave first. If I'm going to bend the foam, if I'm going to bend it inwards, it is going to appear somewhat like this. If I'm bending the foam with the nails fixed in it, they are also going to bend to a certain point, yes or no? Did you understand what did I say? This was the actual foam with the nails fixed perpendicularly to it. And these nails represent the normal rays. So what did I do in the second case over here? I am going to bend the foam inwards. when I'm bending the rubber foam inwards and making a C shape. Okay, so basically these nails are also going to bend to a certain level. They bend to a certain level where I can draw some imaginary rays which meet at a certain point. What are these rays called as? Converging rays. And what will this point called as? The converging point or the point of convergence. Did you understand? So this shape of the rubber foam represents the concave mirror. Do you understand now? If this represents the concave mirror, the nails here represent the normal rays. So the normal rays are converging and meeting at a certain point, which is the convergent point in a concave mirror. So you need to understand that in a concave mirror, the normal rays are going to meet at a certain point. This point in further detail is going to be called as the center of curvature. So for your convenience, I am going to write here as the concave mirror. Remember, in the concave mirror, the normal rays are going to converge. The point at which they are meeting is called as the center of curvature. Remember, the point at which the normal rays are meeting is called as the center of curvature. That is why the concave mirror is also called as the converging mirror. In the third case, okay, I'm going to bend the foam outwards. Do you understand now? In this figure, I was actually bending the foam inwards. In this, I am bending it outwards. When I bend it outwards, the nails are diverging from each other. They are not meeting at any point over here. Do you understand? Because I have bent the foam outwards. When I'm bending it outwards and they are diverging, it represents my convex mirror. And these nails still represent the normal ray. So we need to draw an imaginary line for each of these nails, which is going to which are going to meet behind the mirror, and where they are meeting, that particular point will be called as the center of curvature. Remember, the convex mirror is called as the diverging mirror. Do you understand now? Because it is bent outwards. Here, I'm bending it inwards. That is why it is called as the converging mirror. They are meeting at a certain point. This is not meeting at a certain point. And I myself need to draw the virtual lines behind the mirror so that they meet at a certain point of contact, which is nothing but the center of curvature. Okay with everyone? Okay, what was this? This was the rubber foam. You can also consider the rubber foam or the sole of your slipper. What did I do in the first case? I'm just cutting it in a rectangular shape and I'm fixing 4 nails. What do the nails represent? They represent the normal rays. So here, what did I do in the second case? I'm bending it inwards. What happened to the nails? They are converging at a point, and that point is called as what? The center of curvature. Okay, what is the concave mirror also called as? It is called as the converging mirror. Fine. Now, in the third case, I'm bending it outwards. Are the nails coming to a certain point, or are they converging to a certain point? Can I draw the lines on this side? No, because they're diverging from each other. They are moving apart. So I need to draw some virtual lines behind the mirror so that they meet at a point of contact called as a center of curvature. What is the convex mirror also called as? It is called as the diverging mirror. Further, we are going to study the essential points when we consider the mirror, like the principal axis, the pole, the focus, the center of curvature, and so on. Let's go in further detail. So we need to understand few terms regarding these mirrors. So the first one being C over here. Okay, this is a concave mirror that I'm going to consider, and if I draw the lines over here, they represent the silver furnishing, which is usually painted back behind the mirror. Okay, these lines represent this because we have studied this in class 8. The silver furnishing is represented by these lines over here. So we need to understand few terminologies related to concave and convex mirrors. The first one being the C. What do you mean C is here? Because center of curvature. How did I get this? Center of sphere is center of curvature. I have told you earlier the concave mirror is nothing but a part of the sphere. So sphere is also going to have a center. Do you understand? So that center of the sphere is called as a center of curvature. Definitely you have cut the sphere into one half. This is one half of the sphere. Okay. The half part of the sphere is being considered over here. Definitely the center is also going to be considered. So you need to remember the center of curvature is nothing but the center of the sphere. But when we are talking about spherical mirrors, we are only going to refer it as the center of curvature. Okay. Now, any point, any line drawn from the center of curvature to any point on the mirror is called as the normal ray. The line drawn from the center of curvature to any point on the mirror is called as the normal ray. I am repeating it for you. Do you understand now? And the line which is passing through the center of the mirror, the horizontal line that you see over here, is called as the principal axis. The midpoint of the mirror is called as the pole or the optic center. So these were the parts that you actually need to know. Okay, the distance between P and C, which is nothing but PC, is going to be called as the radius of curvature. Ever heard about the term radius before? Of course, in maths, geometry, yes or no? When we draw a circle and we have a center, any line from the center to any point on the circle is nothing but the radius. Okay, in our case, it is going to be P to C. Do you understand? You need to remember this one. The distance between the pole and the center of curvature is called as the radius of curvature. C is nothing but the center of curvature. The line between the center to any point on the mirror is called as the normal ray. The horizontal line passing through the center of the mirror is called as the principal axis. The midpoint of the mirror is called as the pole or the optic center. Why do you think it is called optic center? Optic. What do you mean by that? It is all related to light. What are we studying over here? Reflection of light at curved surfaces. Definitely any light related terminology will also come under the great concept of optics. So now moving on to the second diagram that I've drawn over here. So now that you know that P represents the pole, C is the center of curvature, this dotted line that you see here is nothing but the normal ray. Okay, the R that you see over here is nothing but the incident ray, which is coming from a certain source. So let our source be the sun. Yes or no? Now, can you tell me, can you calculate the distance between the sun and your mirror? Okay, you definitely know what is the distance between the sun and the earth through internet and by googling it, of course. But now, can you calculate the distance between the sun and the mirror? No. Okay, so we are going to consider the distance between our source, the light source, and the mirror to be infinity. Do you understand? That is an estimation. Okay. So now if I consider that my light source is at infinity, then the light rays which are being projected on the concave mirror are parallel in nature. Can you see this incident ray which is parallel to the principal axis? You need to understand whenever the light source is placed at infinity, the rays are going to be parallel to the principal axis. So this parallel ray that you see over here is nothing but the incident ray. Okay, you see this arrow point over here? This clearly represents it is going to strike the mirror. What is going to happen after that? Any ray which is striking the mirror, after that the ray is going to bounce back. There is going to be reflection over here. So once this parallel incident ray is being projected from our light source to the concave mirror, that particular ray is going to bounce back and reflect in a certain direction. This ray which is bouncing back is called as the reflected ray. Now we have all the three rays over here in the same plane. Yes or no? Is our first law of reflection proved now? Definitely yes. What does the first law of reflection say? All the three rays lie in the same plane and we can see them actually in the same plane right in front of you. What was the second law? Angle of incidence is equal to angle of reflection. Definitely, that is also going to be equal over here. Now, angle of incidence is nothing but the angle between the incident ray and the normal ray, and angle of reflection is nothing but the angle between the reflected ray and the normal ray. So, angle of incidence and angle of reflection are also going to be equal. Okay, so whether it is curved surfaces or plane surfaces, both the laws of reflection are valid. Hence, you prove it in this way. Okay, so now further we are going to discuss what is a focal point and what is focal length. So before we move further, we need to understand one more concept. Okay, so we want, if we want the incident rays to be parallel to the principal axis, then we consider the light source as sun, which is placed as infinite, which is placed at infinity. Because I've told you, when the object is placed at infinity, the rays are parallel to the principal axis. What if the light source is a candle and you still want the rays to be parallel? So what are you going to do over here? Okay, can you see this diagram over here? I have a rectangular block to which I have fixed two nails. I have a light source here which is nothing but the candle. I have placed the candle very near to the setup, and I observe in the shadow of the candle that the pins are diverging. So what do I conclude from this? If I place the object very near to this particular setup, the shadow thus formed shows me the divergence of the nails. So what do I have to do so that the nails are in parallel lines? So that the nails are parallel to each other. What do I need to do? I need to take the candle a little farther away from the setup. Yes or no? So now I take the candle a little far at a certain distance till the shadow shows me the two parallel lines or the two parallel nails. Do you understand? So what do I conclude from case number 2 over here? This is case number 1, this is case number 2. What do I conclude from case number 2? As I take the object far away from the setup, the rays which are going to be in the resultant form are going to be parallel to each other. Okay, here the light source is not sun, it is the candle. Do you understand? Fine. So let's try to understand the spherical mirrors a little further. As you can see, this is the incident ray which is parallel to the principal axis. P represents the pole, C represents the center of curvature. Let's find out what is F. Remember, the horizontal line passing through the center of the mirror is called as the principal axis, and this is the concave mirror. Okay, so these are the incident rays which are being projected on the concave mirror. Once the incident rays strike the mirror, the light is going to reflect back. Once it reflects back, the reflected rays are also going to meet at a certain point. The point at which the reflected rays are meeting is called as the focus or the focal point. I repeat, the point at which the reflected rays are meeting is called as the focus or the focal point. Don't confuse yourself with what is the center of curvature and what is the focal point. The point at which the normal rays are meeting is called as the center of curvature. The point at which the reflected rays are meeting is called as the focal point or the focus. Okay, do you understand? Now, can you see the incident rays which are parallel to the principal axis? What did I say you previously? If the incident rays are parallel to the principal axis, this means my object is placed at what? It is placed at infinity. Do you understand? So this means when I place the object at infinity, the image is going to be formed where? It is going to be formed at the focus. Did you understand the first ray diagram that we need to, come across? It is nothing but when the object is placed at infinity, the image is formed at the focal point or focus. Now let's discuss further. The distance between P to C. I told you previously the distance between P to C is nothing but the radius of curvature. P being the pole. Now the distance between the pole and the focal point, what do you think it is going to be? It is going to be the focal length. So the distance between P to F is nothing but the focal length. Okay, so you need to understand one more concept over here, that PF is going to be equal to FC. Okay, now PF plus FC gives me PC. Can you understand this from the diagram given in your textbook as well as on the board over here? PF plus FC is going to give me what? PC. Okay, what is the value of PF? It is nothing but the focal length. So the focal length is going to be represented as small f. Do you understand? And I told you that PF is going to be equal to FC. So what does this mean? If PF can be written as small f, FC can also be written as small f, which is nothing but PC. F plus F gives me what? It gives me 2F. How do I represent radius? I represent it as capital R. So this is the relationship between the radius and the focal length. R is equal to 2F. This means the radius of curvature is twice the focal length. Did you understand? Okay, please go to the concept. Now look at the diagram carefully. Don't you think this represents something that happens in a headlight? This concave mirror represents the shape of my headlight, which is also parabolic, kind of. And this focal point represents that bulb that might be placed over here. And when I switch on the car headlights, they are going to illuminate, okay, and they are going to reflect back. And this is how the rays fall, and you're able to see in the dark, okay. Try to represent or try to compare this diagram to that of headlights. So this was with concave mirrors. Let's discuss what happens with the this was with concave mirrors. Let's discuss what happens with the convex mirrors. So this is the convex mirror. What did I say you? Where is the ray going to strike on a convex mirror? On the bulged portion. What is the convex mirror also called as? It is called as the diverging mirror. Are the reflected rays going to meet at a certain point on this hand side? No, they are not, because they are divergent. This ray that you see over here, which is striking the bulged portion, is nothing but my incident ray. Once the incident rays are going to strike the bulged portion, the rays are going to reflect back and they are going to diverge in different directions. So if you see, this is nothing but my reflected ray. Okay, they don't meet at a certain point. So where is the image going to be formed? How should I draw it? So I am going to consider virtual lines over here. Okay, I am going to extend these lines, extend the normal rays so that it forms a virtual center of curvature. Similarly, the refracted rays are also going to be virtually extended and it is going to form a virtual focal point. Okay, so much of virtuality. What do you think is the image going to be like? The image is also going to be a virtual image. Do you understand? And virtual images are always formed behind the mirror. If you remember what we studied in class 8. I repeat this one. Which kind of mirror is this? It is the convex mirror. On which side are the incident rays going to be projected? On the bulged side. Is it a diverging or a converging one? It is diverging. So what kind of focal point am I going to consider over here? The virtual focal point. How did I draw this virtual focal point? By extending the reflected rays behind the mirror, I am going to draw I'm going to mark a virtual focal point. Okay, what is the nature of the image in a convex mirror? It is diminished as well as it is virtual because it is formed behind the mirror. Now, can you consider this setup to be similar to that of your rear view mirror? Okay, what is a rear view mirror? How does it help you? Rear view mirrors are present in automobiles. For example, the bike, like the ears of the bike. So if there is any car or any truck coming from behind, you're able to see the image of the car or the truck in the rear view mirror. Does the size of the truck appear exactly as that in the mirror? No, it is going to appear very small. It is going to be appearing as diminished in size. That is why those mirrors which are being used in rear view mirrors are nothing but the convex mirrors, and the image that you see is nothing but a virtual image, because real images are always inverted. Okay, so here, remember this one. It is the virtual focal point. The center of curvature is also virtual because they're extended behind the mirror, and the images that are going to be formed is also virtual. Thank you.